Okay, we begin by writing down a definition, and the definition is for that of a one-to-one function. And a one-to-one function is said to be one-to-one if every element of the domain corresponds to exactly one element of the range. What does that sound like? Definition function. Okay. And an important conjunction word, and every element of the range corresponds to exactly one element in the domain. You have to know this for the test, which it's it's basically the same as the function, right? You just gotta put the word and flip it around. So here's the real world example. We got some basketball players in here tonight. Two, two, three. There we go. All right. So suppose I look in the box score tomorrow. Is it possible to see that Jake, Sean, and Jack all scored exactly 6 points in the basketball game? Yes, and we said that that would be an example of a function that they each could be mapped to the same number of points. It wasn't a function if I looked and I saw that Jake scored both 6 points and 10 points in the game. He had to score one or the other. However, in order for it to be one to one, would be this. Suppose I said, who was the player that scored 6 points in the game last night? Would you guys be able to tell me definitively who the single person was? No. So it wouldn't be one to one. But suppose that Jack scored 6, Jake scored 8, and Sean scored 10. And I said, tell me the person who scored 6 points. Could you then definitively tell me? Yes. So graphically, what this means, is I will draw two graphs here. Both of those are cubic, correct? True or false? They are both functions. True. Why are they both functions? They pass the vertical line test. Very good. Now, suppose I were to set this bar that I've created up here at a height of 1. We'll call that a height of 1. At how many places does the green function have a height of 1? 3. So therefore, there's 3 outputs. I'm sorry, there's one output corresponds with 3 different inputs, right? An output of 1 maps to there, and to there. There are 3 different inputs that give you that output. So therefore, this is not one-to-one. How many times does the blue line cross that? Once. And so in order for a function to be one-to-one, it must pass the horizontal line test. It already passed the vertical line test because it's a function. It also must pass the horizontal line test in order to be one-to-one. Why do we talk about one-to-one? One-to-one is interesting because we have to first define one-to-one before we can talk about inverse of functions. What are inverses of functions? Well, in addition, what is the inverse of positive 2? Negative 2. Therefore, if I were to add them together, I get 0. That's why they are inverses, because they sum to 0. And 0 is what we call the additive identity, because anything that you add to 0, you will get itself, right? We've learned that many years ago. And with multiplication, the multiplicative inverse of 5 is 1/5. Because when you multiply together, you get 1. Because 1 is the multiplicative identity, because when you multiply anything by 1, you get itself. That's the definition of an identity piece. So what we need now is we need a function inverse. And function inverses are like this. We switch x and y. We switch the domain and the range. So, for example, suppose I had a function of 1, 2. That's just a single point, correct? What would be the inverse function? 2, 1. Suppose instead of 1 point, I actually had a function rule. Say y is equal to 2x. What would the inverse be? X equals 2y, and then I would solve for y. I would get 1 half x is equal to y. Functions do have inverses, just like numbers have inverses under certain operations. The way that we test to see if they are inverses is we compose them. And we must compose them both ways. We take f of g of x and we take g of f of x. And when we compose them together, we will get out the identity. Remember, what was the identity under addition? 0. What is the identity under multiplication? 1. The identity under composition of functions is x. Graphically, they are reflected over the line y equals x. So you can tell if one graph is an inverse of another by simply looking at the graph and see if it's reflected over the line y equals x. Please take out your calculator. So we already stated one function and its inverse. The first function was 2x. Its inverse was 1 half x. I'm going to put those into my calculator, and I'm also going to put in with bold the line y is equal to x. And what I'm going to do now is so that I can see it better, I'm going to zoom uh, as a square so that it's not skewed in its dimensions. So I zoom square, and as you can see, that's 2x, that's 1 half x, and that's the line y equals x. Does it look like one is flipped over the line and you get the other? Yeah. And so graphically, that's how you can tell that one is the inverse of another. Here's something that you learned a little bit about last year, and then we'll get to some examples, I promise. Just, we could talk for days about the properties of inverses and their connectivity. Um, did you guys ever learn about that type of a function last year? Ever learn about that function last year? You learned barely, but you did learn a little bit about logarithms. And I will tell you that if you want to know and understand logarithms better, you should understand inverses better. Y equals e to the x, the graph looks like that. Y equals natural log of x is actually the inverse of that. And what that means is if this passes through 0, 1, then this should pass through 1, 0. If this has a horizontal asymptote of the x-axis, then this will have a vertical asymptote of the y-axis. And if you were to graph them, you'll see that 1 is simply reflected over the line y equals x. They're very, very closely related. And so that's part of the beauty of mathematics is the connectivity all the way around. Let's try some basic examples. Oops, we don't know how to do that. Let's try some basic examples that you're going to see on your test. Given f of 2 is 3, f of 1 is 9, f of negative 3 is 8, f of 4 is 5, and f is 1 to 1, find the following. This says f inverse of 8. Before we do f inverse of 8, let's try this. What's f of 1? 9. That means if I give you an input of 1, what is the output? Okay, so you have this coordinate 1, 9, right? Well, we're switching that up. When it says f inverse, that means the following. What gives you an output of 8? What input gives you an output of 8? Because wouldn't you agree that the point negative 3, 8 is a point on that function? So therefore, f of negative 3 is 8. F inverse of 8 is negative 3. Again, the x and the y's switch. So what would be f inverse of 3? 2 is the input that gives you an output of 3. F inverse of 5. 4. 4 is the input that gives you an output of 5. And finally, f inverse of 9, 1. You can see that 1 was the x value that gave you an output of 9. Okay, so can we handle that first basic example on our test? Okay, let's try something else that I think you'll do quite well with. It says find the inverse of the following functions. You should also be able to find the inverse, and we do so by switching the x and the y values. So instead of writing y is equal to 2x minus 5, I can write x equals 2y minus 5. And then we should solve for y. How do I do that? Add 5 and divide by 2. So 1/2 x plus 5 over 2 is equal to y. This is the inverse of that. Yes, in fact, your book will often write as x plus 5 over 2 instead. Yep, either way is fine. Is a line 1 to 1? Does a line pass the horizontal line test? Yes, it does. Okay, so therefore, we can be confident that it has an inverse. If it is not 1 to 1, it's a lot trickier to find the inverse, okay? Can't always do it. That gets a little bit more complicated. We'll get to an example later on. How about this one? Y is equal to 2 minus x over 3x minus 4. So I have to switch and say x equal to 2 minus y over 3y minus 4. What makes this problem more difficult? Fraction, and there's more than one y. We're trying to solve for y. Well, there's two of them. Well, we learned this first quarter. We cross multiplied, and we got 3xy minus 4x is equal to 2 minus y. The difference was in first quarter, we were solving for x. What are we solving for now? Solving for y. So what do I have to do to solve for this? Take the y out, but before I take the y out, I should get the y is on one side. So 3xy, and then plus y is equal to 2 plus 4x. And so I will factor out a y, and I get 3x plus 1 equal to 2 plus 4x. And then I divide. Put it in. That's the inverse of our original function. If we graph these on the calculator, we see them flipped over the line y equals x. We did that fourth or third hour, but we're not going to do it now because I just want to save some time. Okay, flip it over to here. 2 minus 3x to the third, is that 1 to 1? That's a cubic. It's shifted up 2 units, and it's stretched by a factor of 3, and it goes down. But that is 1 to 1, isn't it? So we can be confident that its inverse will be 1 to 1 as well. Okay, and it will be a function. So we have this will be x is equal to 2 minus 3y to the third. How do I solve that? solve for y by, so x minus 2 is equal to negative 3 y to the third. Divide everything by negative 3. We'll do what Raylan did, and we'll say that x minus 2 over negative 3 is equal to y to the third. And then what should we do to both sides? Can I take a cube root of a negative? Yep, I can. I guess now we have an irrational denominator. Let's just not worry about that right now, okay? I'm not really excited about that. So let's go y is equal to the cube root of x minus 2 over negative 3. And obviously, we could rationalize the denominator, but let's not do that right now. Okay? Yes, you would need to do that. If you want to, it's just going to take us more time. We got other stuff to do. You guys know how to rationalize the denominator. Well, how about this? What would be the first step to rationalize the denominator? Get rid of the negative, thank you. Put it on the top. And now you multiply by the root of 3. Yep. By a cube root of 3. So, all right, let's look at D. 4 plus the square root of x plus 1. 4 plus the square root of x plus 1. What does that graph look like? What is the parent function? Yep, square root function. And it's going to be shifted to the right or left? Left 1 and up 4 units. So this is, you're comfortable with that being my graph, right? So wasn't it nice we spent all the time learning how to graph that stuff? This is where you really want to apply it. Every time you see a function, you want to think, what does it look like? Okay, so we want to find its inverse. Is this 1 to 1? It is. And so therefore, I should be able to find its inverse. So I will say x is equal to 4 plus the square root of y plus 1. How do I solve that? Minus 4, so x minus 4 is equal to the square root of y plus 1 squared. So x minus 4 quantity squared is equal to y plus 1. And x minus 4 quantity squared minus 1 is y. What does my new graph look like? A parabola. What's its vertex? 4, negative 1. Pay very close attention to this right now. This has a coordinate of negative 1, 4. So its inverse should have a coordinate of and does it? Yeah. See that? Second of all, this is a parabola. Doesn't it look like if you reflected the green graph over the line y equals x, you would get the red graph? But if this is a parabola, I also have that part to it, don't I? If you take this green graph and reflect it, you don't get both the red and the blue, do you? So why, when I took the inverse, did I come up with both pieces? Which step here gave me the second part of the graph? The squared. When I squared both sides, that created the extra piece. And so, therefore, we have to limit the domain to only show the red. So this is not complete. This is only part of the inverse. X minus 4 quantity squared minus 1 equals y. 4x, what? I want to limit x to only give me the red graph. So x has to be what? Greater than or equal to 4. That way, I don't have the blue. I only have the red. Does that make sense? If you would list this as the answer, you would get 2 points on the test out of 3. Or get the third point, you would have to list this. You need to know that this graph is different than that graph when you look at the inverse. Okay? All right. Last 4 examples and we're done. You'll have some time to work. This is the third and final step that you need to be able to accomplish when you do your test. And it says, use the property of inverses to determine if f and g are inverses of each other. Well, what we want to do is we want to compose. We remember that in order to determine if they are inverses, we have to state that f of g of x is equal to x. We have to say that g of f of x is equal to x. So I will compose. I'm getting too excited here. Just, how much of your life do you spend using addition and subtraction stuff? We're tired of those operations. Let's use composition. All right. So we're going to compose these, and if they are inverses, we should get x. F of g of x. We practiced this already in our assignment, didn't we? So we have 3 times, and I will always write my input in parentheses. X plus 5 divided by 3 is 5. What happens? I get x plus 5 minus 5 is equal to, and that's what I want to get. Right here, because x plus 5 minus 5, the 5's will cancel, right? Yes. I have to come up with x. If I don't, they're not inverses of each other. Now, that's only one side. Composition is not commutative, so therefore you have to check both ways. G of f of x. So now I'll take f and plug it in for g. 3x minus 5 plus 5 divided by 3. What happens? Yes, they are inverses of each other. B, f of g of x. Take that and plug it in for x right there. 1 over the quantity 1 over x minus 2 plus 2. What happens? And I get 1 over 1 over x. Oh no, how do I do 1 over 1 over x? And I will get x. I check the other way. 1 over 1 over x plus 2 minus 2. Uh-oh, how do I do 1 over 1 over x plus 2? Again, multiplied by reciprocal, and you get x plus 2 minus 2 is x. So yes, they are inverses of each other. Look at C. It says f of x is 4x squared. Is 4x squared 1 to 1? Why is it not 1 to 1? It's a parabola, and a parabola does not pass the horizontal line test. So therefore, look at what they did. They restricted the domain. They said for values x greater than or equal to 0. So that means you are only looking at that part of the parabola. Is that 1 to 1? So does it have an inverse? Go ahead on your own, compose those, and see if they are inverses of each other or not. Yes. Any questions on letter C? Okay, then our final example, second letter C, it looks like. For our second letter C, uh, what do you notice about those? The same. Do you think it's possible that a function, its inverse could be itself? Y equals x is one example. Y equals 1 over x. If you were to switch them, y equals 1 over x, its inverse is itself. There are some functions where the inverse is itself. So don't think that just because you see the same thing, that it's automatically no. Let's try this and see how it works out. F of g of x. Get 1 over x to the third cubed. So let's do our powers first. Um, what's 1 cubed? Well, what's x to the third cubed? And what is 1 over x to the ninth? And I did not get x. So therefore, no, they are not inverses of each other. What do you think people will sometimes do when they see this part right here? They'll just cancel them out. Oh, no. Yes, this is definitely a case of voodoo math where you're like, I know what I want to come up with. I want to come up with X. I will just cross stuff off until we get it. Can't do that. It's very wrong. Okay. As you look at your homework sheets that I gave to you, uh, the assignment I wrote on the board is the same as the assignment from your homework cover sheet. You have plenty to work on. You have your previous homework that some of you are caught up with, but some of your putzes you're not caught up with it. So you got to work on that. You also have your assignment for today, which looks lengthy. The fact is, it's not that bad. Some of the problems go by pretty quick. Finally, you have your study guide, which is a full 5 pages, and there are a number of word problems in there. Again, I cannot encourage you enough that when you come to class tomorrow, try to be in a situation where you're ready to ask questions and not simply just get caught up with your work. Because there's something special about tomorrow compared to when you're at home. What is that? Thank you. You've identified me as a special part of your day. I am here, and although I don't have to help you, the fact is that's my job, and I know how to do all the problems. So I would like to be able to help you. Okay. And I am not staying late tomorrow. I will be here today, but tomorrow I'm going home at 3 o'clock. I'm